And welcome to daily videos about thermodynamics. So I'm going to jump right into some problem examples because that's what I plan to do on a relatively nearly daily basis at least. And this is the first problem I want to look at. So the Fahrenheit temperature scale is defined so that ice melts at 32 degrees Fahrenheit and water boils at 212 degrees Fahrenheit. So A is asking us to derive formulas that allow us to convert from Fahrenheit to Celsius and back again. And B is asking us what is absolute zero in Fahrenheit. So I'm going to need another set of facts here so that I can match these up. So we know that 0 degrees Celsius is freezing. And 100 degrees Celsius is the same as the boiling. And so now we know that ice the temperature that ice melts at both in Fahrenheit and in Celsius, and similarly for the boiling point. And now we're going to end up with 2 points. So immediately we should jump to thinking about a linear relationship between the two, because that's the only thing we can do with 2 points is figure out a linear relationship. And so I'm going to let y be the temperature in Fahrenheit. And then I'm going to also let x, that's going to be the temperature in Celsius. So since we have a linear relationship that we're looking at, we're going to be looking at y equal to mx plus b. And we're also going to have, we want to get it into this form, but we're also going to have this handy equation from algebra, which will help us to get into the slope-intercept form. So this is slope-intercept form, and this one is in point-slope form. But point-slope form is nice and easy to work with. So first thing is we should recognize we have 2 points. So the freezing point is 0 in the Celsius scale, and it is 32 in the Fahrenheit scale. So for my y, that's going to be 32. And similarly for boiling, we're going to have 100 for the Celsius. That matches with our x being temperature in Celsius. And we're going to have 212 in Fahrenheit. So now, first thing we need is the slope m, which is just delta y divided by delta x, which is the same as 100, well, let's actually write it out, 212 minus 32 divided by 100 minus 0, and that becomes obviously divided by 100, and this is 180, but we can simplify this. It becomes 18/10, which is the same as 9/5. Okay, so we have 9/5 as our slope, and then we're just going to go right to our point slope form. So y minus 32 is equal to the m, which is 9/5, times x minus 0. Obviously, that gives us y minus 32 equal to 9/5 x. And finally, that gives us y is equal to 9/5 x plus 32. That should be something that probably looks familiar to you if you've ever had to do this conversion. So y is the temperature in Celsius, and x is the temperature in, excuse me, I have that flipped. Y is the temperature in Fahrenheit, and x is the temperature in Celsius. Now, if we wanted the equation going the other way, well, we already actually have this equation, so we may as well use it. We could go right back through from the beginning, but we may as well just go straight from this and solve for x. So that's going to be y minus 32 is equal to 9/5 x, which means that x is equal to 5/9 y minus 32 times 5/9, which is 160/9. So those are our two equations that allow us to convert either from, this one converts from Celsius to Fahrenheit because we just substitute in for x, and this one allows us, if we substitute in for y, to convert from Fahrenheit to Celsius. Now we had a part B. Let's scroll back up just so we can see it again. So that was part A. Part B is, what is absolute zero in Fahrenheit? Well, now we have this handy-dandy equation. And this also is going to require some work from the some prior knowledge. And the prior knowledge that we're going to need is that absolute zero is negative 273, roughly 0.15 Celsius. So absolute zero, we could write this as 0 Kelvin. This is 0 Kelvin. But it's also negative 273.15 Celsius. And so we just need to obviously substitute that in for the conversion. So we know that x is going to be equal to 5/9. Oh, hold on. I'm converting the wrong way, aren't I? Excuse me on that. I keep forgetting x is my temperature in Celsius and y is my temperature in Fahrenheit. So I need to use the other equation. So I need y. I'm going to change the color here. Y is equal to 9/5 times x, which is minus 273.15 plus 32. And that approximately works out to be minus 459.67 degrees Fahrenheit. So that's all for this problem, and I hope to see you again in the next video.